Hello there. Today we're going to be working on an Oceanic-Continental boundary activity that we were assigned in class. So first off, I've got my two sheets of paper, my two sheets of sticky notes right here. I've got my putty, which is going to be representing the lithosphere. It's going to represent the lithosphere since it's basically has a plastic rheology, and get it, putty is both solid and liquid in some ways, because it's solid because you can't move your fingers through it, and it's liquid because it moves in the state of a liquid. So you have that. I've got my sticky notes that I have. Orange ones are representing the magma and the asthenosphere, and any other colored parts represent the upper areas on Earth, the ocean, the continents, everything else. So let's get started. I've got my two base sticky notes. I got my two base sticky notes. Now keep in mind this orange stuff, this orange colored one, it'll be out because I'm going to be putting the spheric thing through it, the putty. So we're going to do the lithosphere since it separates everything. I first snap it, and then I roll it up, and then I put it over so it's not seen. And then I press down on it, and I continue to press down. But what I'm going to do next is I'm going to shade it in. And next, what we're going to do is we're going to do it this way. And now what we're going to do is we're going to continue to do it until no white is showing. And then we're going to work this side. I think that looks good. There might just be a little bit of white. But that represents our asthenosphere. But if we move it in, you can see it's all colored in orange, which represents the asthenosphere, which I'm going to label right there. If you can see right there, the asthenosphere is labeled right there. Now moving on, we have to continue on, which is moving in that process of moving putty to that gap there. And now what we're going to do is it's moving. You got the lithosphere right here, and then it's moving down, and then you've got another part of the lithosphere. Which is right here. Now before we move on, this is a convergent boundary because one, both plates are colliding and certainly have an idea of making a trench. They're creating a trench. Whereas if it was a divergent boundary, they would create a volcanic island arc. So next what we're going to do is we're going to continue on with the upper body. Now lithosphere's under, we're going to continue. These next two layers, one's the water, and then you've got your oceanic crust.
Society of the 17th century, and how that led to divisional strife that was,
Which is right there.
kind of a strong native impact.
And then you've got your trench, which is basically what the convergent boundary is intending to do, create that trench, which there's a point in below that is causing that because of the converging lithosphere. And did you know, fun fact, the Pacific plate is older than the Philippine plate because the Pacific plate has seeped under the Philippine plate and is proven to be older because layers from top to bottom, top are the younger ones, the bottom are the older ones. But moving on, we're going to move trench out of the way. Well, actually, trench is good where it's at. The next thing we're going to do is we're going to add our volcano, our mountains, mountain ranges. Now keep in mind, volcanic island arcs could be because of divergence in the past in that area. And what you got to look at is that the fact that there's these crust boundaries that come across. Now, continuing on, this is also the asthenosphere. I'm sorry. Let's move that up a little bit more. I tell you what. That looks good. Asthenosphere. So basically, this is your continental crust right here. It'd be right there. And the oceanic lithosphere would pretty much be around this area too. So we get the water, the oceanic crust, and the oceanic lithosphere too. So the trench would be right here, and it's hard to say because the trench is what's the main cause of what's going on below because it's happening in the sea. And a mountain range is forming basically due to convergence and possible divergence. Not divergence, but convergence. And we're seeing less and less faults because of that. This is the finished result of my pretty much the Oceanic-Continental Convergent boundary. Let's move everything. This is the finished result. So you basically, so I hope so all you guys got something out of this. Hope you guys got something out of this. And I'll see you later.